What's up?
I followed the girl and she followed me back.
You're famous.
No, just like I mentioned it. It's interesting.
大した少年ですね。いくら水分身がオリジナルの10分の1程度の力しかないにしても、あそこまでやる。だが先手は打った。行け。はい。 人公気取ってピーピー泣いてる。お前みたいなバカはずっと泣いてろ。泣き虫野郎が。あいつはもう泣き飽きてるんだろうな。だから強いっていうことの本当の意味を知ってる。君の父さんと同じようにね。本当に大切なものはたとえ命を失うようなことがあったってこの両腕で守り通すんだ。いいね。僕も強くなれるかな。父ちゃん。あんたのその綺麗な肌見てると切りたくなるね。早く歩け。スピードを見切るか。そうだ。手綱さんを囲んで俺が離れるな。あいつはサスケに任せる。君を殺したくはないのですが、引き下がってはもらえないのでしょうね。おいえ。やはり。しかし次、あなたは僕のスピードについてこられない。その僕はすぐに2つの先手を打っている。2つの先手。1つ目は辺りに巻かれた水。そして2つ目に僕は君の片手を塞いだ。したがって君は僕の攻撃をただ防ぐだけ。何こいつ片手で。片手のインカット。技術戦殺水晶。殺したか。本命かな。修行。力を一気に練り上げ。変わり身の術。女か。遅くなっちまった。
Hey, Kaden. Kadon. I don't know. Kadon, lol. I'm just doing a impromptu, random, like, software engineering lesson for a friend. You guys are welcome to follow along if you'd like. Hello, welcome. I'm gonna start here shortly. Just making sure you guys can hear me, right? And everything. Can you guys read the screen properly? Are you guys able to read everything on here? Should I make it bigger? Okay. Okay, let's start off with what is Python? So Python is any interpreted language. Do you know what an interpreted language means compared to, say, a compiled language? Just tell me what you know on the subject, even if it's very little. Just say anything. Do you have any idea what that means? Okay. So what interpreted means is, let me open up the terminal really quick. So, for example, let me run just the command Python here. You see how now I have this window open where I'm able to type in language, so I can say do a equals 5 and then print a. So you see how I did a equals 5 print a into this little like Python window here? So this is what's called an interpreter. So what that means is that there is a Python executable running, like python.exe, that is interpreting the language, like the syntax I'm putting into the Python window. This is different in the sense, say if I was programming C or C++, instead I would be only able to write code in, say, VS Code, like I'm in now, save it, and then run a compiler like GCC, and then it would compile the file into an executable. So the difference being with interpreted languages like Python, the code typically is distributed in its source code format as it's interpreted, where like the language has to be interpreted every time it's ran. Whereas C or C++, because it's compiled, it's distributed in its executable format, so like a .exe. Does that make any sense? Do you have any questions about that? Tell me anything you didn't understand about that, or tell me if there's anything like you don't understand. Like if you don't understand like what the point of that is, or like what the difference is, I can maybe show you how like C would work if you were to write it. But it's not super important, but it's some of the basics. Backend is more about like with backend you can use any language. With front end you only have well, it depends on the language, but typically like you're talking in a web context, well, you'll only have access to HTML, CSS, and JavaScript. But typically front end really just means client side. In a way, context of use, there isn't much usage. It's kind of just knowledge. Knowledge is power with being a software engineer. And it's also valuable to know these things and for interviews and stuff like that if you're trying to get a job. But let's continue. So next thing is I wrote some code here. So let me move this up a bit. So I wrote this code here. I'm actually going to erase it. So let's start off with how numbers / like integers work in Python. So first off, let's go ahead and write a equals 5. So we have a equals 5 written here. Copilot is suggesting b equals 10. We're just going to ignore that. Try and ignore it. If you see like this kind of slightly transparent text, it's because Copilot is making suggestions for me. I find that very useful. I highly recommend it, even starting out. But anyways, so what VS Code is going to allow us to do quite a few different things where even without Copilot for autocomplete, this is a very, very useful skill. So say, for example, we wanted to interact with A. So we can just go ahead and say we wanted to print A. If we just print A and then build, we will get an output of... So I didn't do print A, I just did print. So if we just do print A, we get 5. But say we wanted to interact with A in a more meaningful way, we can hit period. and then we get some functions here. Sorry, let me see what you're saying. So print is very simple. So what print does is, say I did a, or just this is define something new. Let's say test variable equals in string test, which this means, so Python chooses what type your variable will be depending on what the variable is equal to. So say if you do test variable equals test in quotations, you're making a new string. Like in quotes, like anything put in quotes will be declared as a string. So this is now a string type, like this string type. Or if I do test integer, let's just rename this actually test string variable, and then let's do this one test integer variable. So this would be 1, for example. Or we could have, what other data types? There's lists and dicts, for example. So let's do test list variable. We could do, we have to use these specific brackets, 1, 2, 3. This is a list. And then let's do a dictionary. This one's using squirrely brackets. I'll write it out manually. So squirrely quote key colon equals value. And then you can also use different types of values. Like you can use key2 equals integer. You could do key list and then define a list in here like that. You can also even use dictionaries in here, like key dict, and do another dictionary. There's also tuples. Tuples are kind of like lists, like this, but you just use these brackets instead. I would just kind of avoid using tuples because you can kind of confuse yourself. I pretty much never use them, so I'd kind of just erase them from your brain. You can also use sets. I'm not actually, I pretty much never declare sets like this. Typically, people declare sets using this set variable here. Or I think this is a function actually, or it's a class, my bad. It's a built-in class. You could just call it set. And then you could do like test set variable and use the add function, for example. These are your different types of variables. This isn't everything. So, like, in some languages, I'm trying to think. So, for example, if we were doing JavaScript, let me make a new file, test.js. With JavaScript, if I wanted to, like, JavaScript is more precise with how it declares variables. So in JavaScript, if I wanted to make a variable, I would be doing like let test variable. Actually, there's a few different ways. So if say you have a variable that's never going to change, in JavaScript you could do const, which means constant. I don't know. Test integer equals 1, 2, 3, and then semicolon. And then you could do, I think you can also do like string, test string. I forget. I don't know. I'm not super good with. I think here. So JavaScript also is using interpreted variable types. I think that's what it's called. That's something like that. So like when you do constant test string equals, like what makes this a string is the quotations, and then what makes this an integer is not having the quotations, and then like back to Python, like what makes this a list is these brackets. Like we don't have to officially tell Python it's a list. Like Python figures that out on its own, if that's what you're asking. Like, let's do test string equals test in quotes, and then let's do test string equals test. So if we just do it without quotations, you see how it says error here, undefined name test. So without quotations, it thinks we're trying to refer to a variable. And obviously this test variable doesn't exist. So if we run it right now, we are just going to get an error, test is not defined. And then if we remove that and just run it, it'll work. And back to the print thing. So print, if we do print test string, this is going to print test, like the what's in here in quotations. And then so what print does is print it will print or write a line. Like, so I don't want to use it I don't want to include the word in its own definition. So it would write anything you're telling it to what's called standard out. And standard out is typically like wherever you're running your script in the terminal. That's where standard out is. So if we change this to a list, 1, 2, 3, and we change this to test list, and we do print test list, and we run this again. Look, now it printed the list, right? Let's interact with this list in a way. So let's indice, and let's only print the very first part of the list, the very first item in the list, which in this case is 1. And then let's also then print on the next line, let's print the second one, because remember that Python starts at 0. So if your very first item would be 0, and then your second item would be 1. That's a really good thing to remember. It's very important. So let's go ahead and run this code. We're going to get 1 and 2 as output. It starts like this because of just how computers work. They just start at 0. I think some languages start at 1 as like a thing, but it's like forced, I believe. It's kind of weird to remember because let's say we want to get the length of this list. So we could do print len test list, and it's a length of 3. So here, damn, you can't see it on stream. So when I do print len test list, you get 3 as the output. Even though technically that like number 3 here would actually be indice 2. For example, like if I do print test list 2, it would print the very last item, which is 3. So it's kind of confusing in that sense, but you really need to remember it, obviously, or otherwise you can be referring to the wrong indice with your code. Can I clear this? Yeah, okay. So len is strictly for calculating the length of a variable that you give it. So let's go ahead and change list to a string. Let's do test string equals test. And then we do print, or let's store the length in a variable too. Let's do test length integer, because the length is an integer, by the way. So equals len test string. But what do you think this will be? What do you think the output of this will be? Just like if you had to guess, like what do you think test length integer would be equal to? So that's wrong. So remember that len is trying to calculate the length of this string. And that there's the word test. So yes, the word test has 4 characters, so its length would be equal to 4. So say we do print test length integer. It already tells us the output's going to be 4 because the AI just knows, but let's go ahead and run it anyway. It tells us 4, right? Let's change this back into a list that has 5 numbers in it. And let's go ahead and do test list length int equals len test list. And then let's go ahead and print using a format string, which is also a really valuable skill. Length of test list equal to squirrely braces test list length int. This is a very, very common thing. So if you put f in front of a string, this just means you're telling Python you want to use string formatting, and this will make Python treat anything in squirrely braces inside the quotes as a variable and not as a string. So if we go ahead and run this, it's going to give us the output length of test list 5, right? Let's make this a bit simpler. Let's just go ahead and straight up print test list length integer. Sure, let's work with some strings more. Let's do test string equals test123. Let's go ahead and just print test string. And let's clear this. Let's go ahead and run this code. So this is going to output test123, right? Let's say we only wanted to print a part of the string and not the entire thing. So let's do print test string, and then let's do indice 0. What's that going to give us? It's going to give us t, okay? Now, what if I change the indice to 4? What is that going to give us? What is your guess? So remember that it would start at 0. So 4 is actually the 5th one, right? So actually, I think you were correct 1. So 0, 1, 0, 1, 2, 3, 4 would be 1. Yeah, so 1 was right. Now, let's do another thing. Let's do test string 2. Let's put this as 4, 5, 6. Now, let's just print test string again. We just get test 1, 2, 3. Perfect, okay? But now let's do print test string plus test string 2. This is called string concatenation. Let's go ahead and see what this gives us. That means now we get test 1, 2, 3, 4, 5, 6. Right? So let's go ahead and do test string 3. And let's add another concatenation to right here. Test string 3. Now, what is this going to give us if we run this? What's your guess? Do you have a guess? No. Tell me exactly what you think it will print, like the exact result of the code. Like, what do you think the output will be? But essentially, if your answer means what I think it means, it should be right. But what do you think it'll exactly print out? Yeah, perfect, exactly. So let's go ahead and run that. Right. So let's do another thing. So how about, what if we wanted to combine all these strings into one string and just refer to all of them, right? So what we could do is we could do test string 4, and we could do equal to test string plus test string 2 plus test string 3, and then we can just print test string 4, and then we'd get the entire thing in one variable instead of having to refer to all of them. We could also do it like this, where we could use that format string I was talking about before, where we could do test string 2, test string 3, and just run it. Oops, I have to make this bigger again. Right? What else can we do with strings? Strings are very, very, very important. This is stuff you definitely want to remember. So let's just do it's just the way they did it. It's the only way. You have a few other ways, I guess. Like you can do print, or I should make a string first. So test string equals test, or let's do hello world, and then we can do print test string, or so we need a format string. So just do f, and then test string, and then we can also add more characters here. So like hello world, which just changes to hello world from Canada, and then run that. And then we get hello world from Canada. let's play around with some. Okay, what didn't you understand there? What's confusing? I guess my other point was, say if you wanted to format strings another way, you could do format and then do like 0, and then do from Canada, and then do dot format, and then test string, for example. Or you could do test var, and then do test var equals test string, and this will give out the same output, I believe. Hello world from Canada. So the string format one is a lot easier to do. Like over like as you write more and more code, you're gonna like strongly prefer using the F string like this. Let's try and make a real world example here. I'm trying to think of something really simple that we could use. Actually, let me get something really quick. Currency exchange HTTP API Python example. Let me just get something really quickly we can use as a real world example. I think it'll help a lot for understanding. Are you familiar with how imports work? So, for example, we can do from HTTPX import async client. So what that does is that allows us to use other code. Like, allows us to use code that other people wrote. So, like from HTTPX import async client, if we try and refer to async, so like let's do client equals async client and without anything else here, we have this error here that says undefined name async client. So like we can't use it until we import it. From HTTPX import async client, right? Now the error is gone. So what async client is it's a client for the HTTP protocol, which is the protocol that websites use. There is a website that offers currency exchange information. So this is going to be, actually, let me switch from using async client to just using client. It'll be easier for you to understand. So we declared a client here. Say we want to, so what client gives us access to? It'll give access to some functions. So say we wanted to use client. Say we want to send a request to a website. Yeah, like using import OS. It's the same kind of syntax, but you're importing different code. Like if I wanted to import, like from OS import, I forget what you all get from OS, like path, or I forget everything you get, like make ders, stuff like this. Like you're just importing new functions and like new variables into your code. You're just increasing the access of your namespace. Like you can import so many different things. Like it's such a wide variety. Like it's not just capable of importing just one or two things. Like you can import packages people make on the internet from like the package manager, like py, it's called like py or something like that. Or you can import all the various packages that come with Python. Like HTTPX, for example, is a package that you would install. Like it's made by another developer. It's quite versatile. Like there's it's just a matter of it's using these from is just a way to make your import more precise. Like because for example you could do import HTTPX and you could do client equals HTTPX.client like this. Or say that's only if you have multiple things you need from HTTPX. Like say you only want the client, you would just do from HTTPX import client. Obviously, though, you can't just import stuff that doesn't exist. Like, if you want to import something, someone would have had to have written the code. Um, but like in so many cases, unless it's something like really niche, there's probably some kind of code that exists. But if code's too old, you may not be able to import it without using like a really old version of Python. Something to keep in mind. But like you can do import requests and do requests.get https/google.com. You could do like from https import client http client equals client.get google.com. I'm gonna put these at the top. Does each import have to be something included in the from or included in the OS? So import can import any code that doesn't exist in like whatever file you're currently running, as long as it's Python and it knows like where it is. Like, say for example, this is actually important. Good thing you asked that question. So say for example, we make a new file called external code.py. And this is our main file, right? So say there's some code we rewrote in here. So let's just do a variable, external variable example equals example 666 example 666, right? So if we just did print, let's actually get both of these open at the same time. So if we just go over to work py and we do print external variable example without importing anything, you see we have an error here, undefined name, external variable example. So how do we access external variable example? Give me what you think you would import. Like, what do you think I should write here to import external variable example? Keep in mind it's named external code.py. I haven't necessarily. I doubt you'll be able to get this, but I'd be real happy if you can get it. But I'll give you one. Just say your best guess, and we'll move on. um, Tell me the exact code, like your best guess at what code I will write here. Like, tell me the exact code you think that will go here. So it should be from something, import something, or import something. You get it? Give me your best guess. Just give me your best guess. If you don't get it, it's fine. Um, Tell me the exact line I would write here. It would be from something, import something, or just straight up import something. Like what would I write here? I want to get access to external variable example from external code.py. These files are both in the same folder. We're trying to run work.py and we want it to get access to this external variable here. Kind of close, not really. So what you would write here is you would write import would be needed. So wrong about there, wrong about the code as well, but that's okay. No worries. We all start somewhere. So what you would write is you would write from, and then you would here you would be putting the file name. So in this case, that would be external code. We do not include the .py. That is not how it works. We do from external code, and then we do import external variable example. And now this error goes away, and if we hover over it with our mouse, it tells us that it is a string that is equal to this 666 example 666, and then we can run the code, and it works. So that's how imports work. So if we wanted to import without using from, what we would do is we'd write import external code, and then you would do print external code dot external variable example. Does that make sense? You need more examples. We could also define functions. So say we do define external function. We could do print hello from external function, return none. And then now we can do import external code, and then we can do run the external function. This is a comment, so we can do external code dot external function, and then okay, so I think you're maybe getting something a little bit confused. Like say in our folder here, we have a few files. We have external code.py, we have work.py, which is delete test.js. We don't need that. It's a little bit confusing. So we have a few files here. Let me clear an ls again. So we have external code py and work.py. So if we do python work.py, we get hello from external function, which is our external function here from external code.py. But we ran work.py, right? Which is this code here. So we ran work.py, but we're executing code from external code.py. But now what happens if we run external code.py? So Python external code.py. Nothing comes up. Why? Because external code.py, all it does is define a function. It doesn't call this function. So this is another little cool thing you can do. So you can actually detect in Python what file is being ran. So in here in external code.py, we could do if name equals to main. We can call external function, and yeah, right. So we can call external function, and if name is not main, we can do something else, and say like this is a module, not a script, for example. So now, what if we run external code again? Okay, now we're getting hello from external function. That means this code here is running. Are you familiar with breakpoints? I'm assuming you're not. VS Code has this feature called breakpoints where you can click here and it will pause your Python process right when it reaches to this line of code. So let's go ahead and run this again. So let's run this. Now, you can see here VS Code paused when it reached external function execution, like this line 6. And it's paused, right? right? So how did we get that to happen? So we ran external code.py, which makes name equals main. So let's run that again. So Python external code.py, hello from an external function, because it's executing this. Breakpoint didn't trigger because I ran without debugging, but so now let's go ahead and run work py. So it's run work py, and instead of breaking on line 6, it's gonna break on line 8. This is because this name variable, it determines, like, this name variable basically knows what code is being if name is equal to underscore main underscore, it means that this code is the file that's being ran. Like, I'm trying to think of a good way to explain this. Okay, so like, if you run external code.py directly, if you do Python external code.py, that means main, like underscore underscore name underscore underscore is going to be main. So let's go ahead and run this code again, and it's going to break point here, right? What is, so like now if I hover over name, it tells us what it's equal to right now, and it's equal to main, and it's equal to main because we ran external code.py. But if we run work.py instead, name becomes external code, right? Does that make sense? And if so, we can try and maybe show what I mean here as well. We can do if name equals main, then we can call external function. If it's not main, like if our file, like if work.py isn't being ran, we can do work.py was not ran, right? And if we run this, what did I run here? So I ran work.py, and it says if name equals main, call the function. If not, then run this, and it called this function. It's a little bit confusing. It's not, this isn't like the most basic thing ever. I'd say it's maybe like a slightly more intermediate concept to understand. So I wouldn't be surprised if it's confusing. Let me try and give you a more realistic example. So let's change this to being called main.py. And let's change this to being called the util.py. This is a more realistic example. So say this is our primary file that we're working on. Say we want to use it. So from HTTPX import or just import client, and we'll call this class main, and then we'll define an initialization function, and we'll define self, and then we'll define self client as client, or as we'll define self.client as a new initiated, so client is a class, and if you like execute a class, it calls its initialization function, and you get like a new version, like a new instance. This basically is creating an instance of client, and storing it inside of our new class here called main. And how typically you'll see Python code written is it'll have if name equals main, then what's initialize our class main, which would be main instance equals main, and then now that it's initialized, so clients aren't a necessary part of code. Like this client I'm referring to is like it's basically what's the word I'm looking for, like programmatic, or because it's basically a way to browse the internet from Python. Um, like this HTTPX client is specifically for sending web requests. Like if I want to send a request to google.com or something, I would use client for that. So it's not something you'd use in all of your code. It's specifically something you'd use in code that you want to send web requests with. But you can use multiple clients. You can define as many as you'd like, but typically you just want to use one. You can use imports just about anywhere, but it's recommended typically that you do all of your imports at the top of your files, instead of doing them like as you need them, if that makes sense. Like it's in Python, typically people will expect the code to just not run if some of the dependencies are missing. If you've ever heard people use the word dependencies, they're referring to imports. So like say for example, you tried importing something that you don't have installed, you would get an error. So like if you do from I don't know, something import something else, right? If there's an error, this because the import can't be resolved, like it doesn't know what you're trying to import. If that makes sense. So this is how code typically kind of looks like with modern Python. Yeah. Here. So let's make a quick little script. So from HTTPX import client, from Colorama import force, and init, and let's run init auto reset true, and then let's make a class main init self.client equals client. We don't need this stuff. Oops. And then if our name equals main, so if main.py is the file being ran. This is just a comment, by the way. Like this isn't code. I'm just putting this stuff here to try and make it easier to remember what the code does. And then so if main.py is a file being ran, let's make a new instance of main. So main instance equals main. And let's make a function in here called let's make a new function called get Google. And you have to do self, and we don't need the URL argument. So, and then we can do HTTP or here Google response equals self.client.get Google's website. Oops, I didn't mean to do that. And then we can return the Google response. Okay, so for example, right now, let's set a breakpoint on Google response. So right now, if I ran this code, do you think the breakpoint would trigger on Google response? Again, the breakpoint would only trigger whenever line 11 is being executed. Self is a variable that is used inside of classes. So, what's a good way of explaining this? Let me make a new file really quick. Testing.py. So, let's say, for example, you have a few ways of writing code. There's two main styles, and one is called procedural, and the other is called object-oriented. I prefer object-oriented. Some people prefer procedural code. So procedural code looks something like, so people would do like say from HTTPX import client, from Colorama for init, and then people could do define request Google. and then they could do we could do client. Oh, wait, oops, we have to do a caller init, and then client equals client, and then we can do Google response equals client.get. Let's just actually write it out, and return Google response, and then we can do again if name equals main. So if testing.py, the file is being ran, we can execute request Google, right? So this is procedural code. Main difference being, so like say I wanted to add a function to this code, and say I wanted to use request Google, like the function. So now, basically, the way this code is written, it's forcing me, if I want to refer to request Google, that I have to put code in after I define request Google. So if I do request Google here, it works. But if I move request Google to up here, it doesn't work. Because like there's an error here because it's not defined yet. Like it gets defined here. But say if we go back to our other file here, I can actually do like say define new function self, and then I can just do self dot get Google, right? Even though this, like, see, you know what I mean? So I could do like another function self, and then I could do self dot get Google. I can do get Google from the front and from the back, like, you know what I mean? Self is like so for example, like say we did define yet another function, and we just return none. So we could do yet another function, right? Or we can define def yet another function here, self, and remember, keep in mind that this one is indented inside the class and also has self here, but then we can, so now here we can do either yet another function, or we can do self dot yet another function, and these are referring to two different functions. Like without self dot, it's referring to this one, and with self dot, it's referring to the one here at the bottom. Does that make sense? So like self is just like a different namespace, if that makes any sense. Like when you're writing code here, you're like, and you're using self, you're referring to the class's namespace, like you're referring to stuff inside this class. So this init function, this function is basically called initialize. This function is called when you use this here. Like you see how, like this, so this is class main. This is class main. But say if I just remove the brackets here and I just do main, then init doesn't get called. Right? So like if I just do this, like this code here doesn't get called. Let's like just do print main has been initialized. Right? So if I do this code won't run. There's like here, let me clear this so you can see it. So let me run this again. So this won't run because the brackets aren't here. But then if I add the brackets, now this code will run. Main has been initialized, right? So like when you add the brackets here to like when you declare a class, like when you're making a class instance, this brackets means you want to run the initialize function. So I was actually just about to get to that. So how does return work? So let's make a function called I don't know, modify list, okay? And we'll take an argument as list variable, and we will return list variable plus well, actually what we'll do is we'll take list variable and we will append the number 4 to it, and then we will return list variable. So then we can do our list equals 1 2 3, and then let's do print our list, and then let's do new list equals modify list our list print new list. So let's go ahead and run this code. So first one we get 1 2 3, and then the second one we get 1 2 3 4. So how does this work? When we run modify list, we give it the argument our list, and it takes our list, which would be list variable inside of its namespace, and it appends 4, and then it returns the new variable. Return meaning like, so when we do new list equals modify list, new list is going to be equal to whatever modify list returned. So if modify list returns none, then now it's going to, instead of printing 1 2 3 4, it's going to print none, right? Does that make sense? So say we change this to in a string, and we run it again. It's going to now print string. We follow the sequence each function, or whatever it's called when it's run. Would you follow the sequence each function? I'll try and re-explain it because I'm not sure exactly what you're asking me. So let's make another example. So this is how you define a function, because I think this is a part you're also like, what is a function? If you want to make a function is like a reusable piece of code. So like define add number to list, right? This is going to be a function we're using. So, and we want, for our function to work, it's going to need a list. Like the person using the code is going to need to submit a list to it, and it's going to need to submit a number that it wants to add to the list, right? So we can give it we give it arguments to do that. What arguments are just a way for you to submit data to a function that it can use. So in this case, we're going to declare the number argument, and then we're also going to declare the list variable, number variable, and list variable, right? And then we do, so if you want to add a number to a list, we'd want to append the number to the list. So what we would do is we would do new list equals list variable copy, and then we would do new list dot append number variable, and we return new list. Okay, now let's go ahead and print add number to list, and we will give it 5. Let's do number variable equals 1, list variable equals 1 2 3 4. Actually, we'll change number variable to 4, and we'll do list variable 1 2 3 4. And let's go ahead and run this code. One, two, three, four. Does this make more sense? Like a function returns data. Like if you're procedurally running code, right? Like A equals test, B equals 1, whatever, and you have like your function, test function, whatever. C equals test function. Now let's go ahead and print A, print B, print C. So what do you think? What do you think print C is gonna output? Like, Tell me exactly what you think the output will be when I run this code. Keep in mind, this doesn't have a return. So this means whatever this function is going to return will be the default of like whatever, like Python has a default return. And since this doesn't have a return inside of it, it's going to return the default value. You probably don't know what that is, but take your best guess at it. Tell me what you think the output will be when I run the code. Which, keep in mind, the output will be whatever these three prints are. So you got the first two prints right, but the last one is wrong. I'll give you one more try. So now remember that this is strictly printing a string. It's not returning the string. So you're right in that this function will be called and it will print this sentence. This is a test function, but you're missing the very last print here. This will also print something. It will print whatever this function returns, and it's currently returning. It doesn't have a return, so you're almost right. You're almost there, but you're missing this last print here. What would this print? It prints the return of test function, and there is no return. So what would it be? You could just take your best guess, because I imagine you don't know. It's kind of obvious. You're probably overthinking it. Nope. So let's go ahead and run the code. So what does it return? It returns this is a test function. Actually, wait 1 second. I don't think it should have. Okay, yeah, so that's right. So you were a little bit wrong, and I thought you were more right than you were because I totally forgot that this would have printed first. But it's okay. You had that general idea right. So how this works is this: since we're just defining a function here, this code doesn't actually get ran yet. So we define our function, and then it goes on to here, defines A, defines B, and then now to define C, it has to run the test function. So now finally this code gets ran. So this is our first print that runs. And then since this is our first print that runs, we first get this is a test function. And then since this is the second print that runs and it's printing A, which is equal to the string test, we get test. And then we print B, and B is equal to number 1, so we get 1. And then we're printing C, and C is equal to test function executed. And since when this function is executed, it doesn't return anything, that means it returns none. Python by default returns none. Okay, so now what if we returning something? Say we return test function return string, right? Now let's run this. Or actually, before I run it, what do you think the output will be? Okay, let me show you one thing. So let's remove all of this code here at the bottom, and let's just keep the function in here, and let's run this code. There's no output. So why is there no output? That's because this function isn't being ran. So if we go ahead and add that code back, where is this function being ran? It's being ran here at C equals test function, right? So if we run the code again, it's going to execute here, right? So now you can see down here, nothing is printed yet. So let's go ahead and let it execute the C equals test function. And you'll see that, boom, you get this is test function. This is a test function output. And then now it's moving on to print A, print B, print C. So like when you're defining a function, it doesn't get ran until you call it, right? So like let's breakpoint inside the function. This stuff is never gonna Wait, let's clear this first. Okay, so let's run this again. There's no output here. These codes do not get ran. And then let's just do test function with brackets. Let's run it. And then now the breakpoints are, so now these lines get executed and the breakpoints trigger. And we can run. Now this is a test function, right? I believe you're referring to breakpoints. So VS Code supports breakpoints. All you have to do is click this little red dot here, and this will trigger a breakpoint when the code on the line is ran. So if I breakpoint 2 and 4, this will breakpoint this print function and the return. So if I remove this test function call, say I comment this out so it doesn't actually run this code, nothing happens. The breakpoints don't trigger, but I comment it back in, so now this function gets executed. Now the breakpoints trigger because the function's getting called. This yellow is just indicating that it is paused on this line, like execution's paused on this line. And then it has a little, you're not able to see everything. Let me adjust this really quick. So, I have this little controller here, and if I hit continue, it goes to the next line. And then I can stop it here. Or I can restart the code. And then you can also step over, step in, and step out. Step out, step in, step over, stuff like that. This stuff, these breakpoints are really useful for debugging and like for teaching purposes. So let's try and are you understanding return yet, or should I give you more examples? Do you need more examples of how functions work? So let's do like string concatenation. I think you need to understand more about how args work. So let's do def. We're going to define string concat, okay? And we're going to give it args string 1 and string 2, okay? Now, let's just do print string 1, or let's do print string 1 is string 1, and then print string 2, and let's return string 1 plus string 2. And let's go ahead and do string concat, let's just do results equals string concat hello and then world. And let's print results. So tell me, what do you think this function will output? What do you think the whole output will be? Like when I run this code, what will the output be exactly? Let's not run the whole thing yet. Let us run some of it. So we'll run it up to, so results equals string concat ran, and then it executed these two prints, and then it's paused on the return. So first we get string 1 equals hello, string 2 equals world, as these prints are doing that. And then if we go ahead and get continue and go past the breakpoint, it will execute the last print, which is results hello world with no space. Let's go ahead and change the return. Let's go ahead and also make this a format. Let's do string 1, string 2 with a space in the middle and run it again. And once again, the breakpoint's still there, so it didn't run fully yet. But let's let it run. Let's just remove the breakpoint and let it run. So now results is hello world with a space in between it. Let's try and make another example here. So let's do def list modifier list variable, and let's do list variable dot append. Let's do for integer in range 100 list variable dot append integer return list variable list. Let's do our list equals this, and let's do print before our list, and then let's do after the list equals list modifier with our, let's do list variable equals our list, and then do print after list. So I haven't taught you about for loops yet, but I think it'd be a good time to transition into that. So what do you think this will look like? What do you think the output of this code will be? Dude, you don't have to write out the whole code because we're adding 100 things to the list, so you don't need to write out every single one. But just tell me what you think it would be. No worries. No worries. So let's make another file just for showing you how fors work. For loop test.py. Okay, so for integer in range 100 print integer. Okay, so what's your best guess at the output of this code? Wrong. So I'll give you one more hint. How for works is it is going to execute the print integer function. I mean, sorry, it's gonna execute line 2, which is print integer. It's gonna execute it 100 times. So that means there's gonna be 100 lines of output. Do you think they'll be the same? Do you think they'll be different? What do you think those lines will be? Blank? No, it's not going to be blank. So it's going to be printing whatever integer is equal to. Let's go ahead and run the code. So, oops, wrong thing. There we go. So let's go ahead and run it. And as you can see here, 0, 1, 2, 3, 4, 5, 6, all the way up till 100. You can, I don't want to, here, you can just see it, 100. So how does this work? So how it determines how many, or like how this works is range. Literally, so range literally just returns a list. Range returns a list of numbers of 0 to 99. So like this. And how for works is it basically for is like saying for means run the code inside the loop for each number or for each number in the range. It's a specific for code is doing that. Not all for loops are going to be just reading like numbers. I can try and give you a real world example in a little bit. Yeah, sure. So let me give you a different example. So let's do username list equals obnoxious the god, like some whatever, right? Now we can do for user in username list print user. So okay, what do you think this code will output? Let me know. Your time. Yep, that should be right. Let's just run it. Yep, so in subsequent lines, we get that. Let's go ahead and use the function now. Let's define add username to list. Username. Let's define our username list at the very beginning. And is this call username list.append? And yeah, I was gonna say I think we should stop in a little bit because I'm also getting tired. But let's just finish this up. Let's just finish this up really quick. So I want to finish up with returns and like these functions here. So this is the last thing. So let's do this function add username to list. The way you add an item to a list, or at least you add an item to the end of the list, is using the append function. At least this is the function that lists have. So this is a username list, right? So you can username list.append because the append function will be available as this is a list. So for we can do new users equals just obby and I don't know, Robbie, okay? And then we can do for new user in new users. We can do add username to list. Username equals new user. And let's print for and let's print an after. And let's go ahead and execute this function, or execute this code. And now our before is this obnoxious the god, I'll be the god, right? And then our after contains obby and Robbie, like from here. And the for executed this code twice. with username equal to new user, with new user switching between Obby and Robbie, right? And I want you to be able to remember how returns work, because I feel like you're having a really hard time understanding that. So this will be the very last thing. So if you want to define a function, new function, right? And we return fuck, right? And we do print new function, right? What is this gonna print? What is the print? What is the output gonna be? Tell me. If you remember, if you understood anything I've said, you need to get this right. What is the output gonna be? The return is, so like when you call a function, like, okay, so like if I do new function, right, with no brackets, like I just do this, what happens? Nothing happens. There's no output, right? But say I put this brackets on, now this thing is gonna get called. So like if I put print hello world, for example, with no, let's just do no return, okay, and let's do that example again. So there's no brackets, and I run this code, nothing happens, right? But now I add brackets, now that the print is gonna get called, which means like there's the brackets is telling Python to execute this function. So right, okay, let's remove this again and just make it return fuck, right? So if we do results equals new function with no brackets, and then if I do print results, right? So if I go run this with no brackets, right? If I just do print results, I get this weird function thing. Like, so it's literally trying to print the function, and it's not trying to print the results of the function. But we don't want that. We want to run the function, and we want the results of the execution. So now we tell Python to actually execute the function by giving it the brackets, and now we print results. So we restore the returned results of the function into results, and then we print results. So now let's run this again, and now we get fuck. So why did we get fuck? We get fuck because the new function was executed and it returned fuck, right? And we stored the return into results. So let's change this one more time. I'm going to give you one more example. You got to get this one right, okay? Define good function. And we return list equals, new list equals this blank list, for I in range 10, new list that append I, return new list. And we do results equals good function, print results. Okay, so what do you think this output will be? Return is, so like when this code return, like, so like when you call good function, this code will get ran. Like this code starts getting ran here, like this stuff. And before it goes on to this print, it has to run all of the code inside the function. And then when the function's over, it returns back to here, and then it continues to the next line. Does that make sense? Like how, so like result equals good function. Good function is executed. Then we go over here, we execute this line, we execute this line, we execute this line. And now we have to return to where we were before. So we return new list, and that means we return back to here, and we store new list into results, and then we move on to the next code and we print results. So what do you think the output of this will be? So reminder, so like the result, when we print results is going to be whatever a new list is. So we're using a for loop, which is gonna, and our for loop makes it so that new list gets appended a number 10 times. So the new list is gonna have 10 numbers in it. Okay, let me give you a simpler one. Define simple function. Return shit. Results equals simple function. Print results. Okay. What is the output going to be? Let's go ahead and run the code. The result is shit. Why is it shit? So results equals to the execution, results of simple function. So the result of this function is shit because it's returning shit. So if we say we put a variable inside the function, string variable equals fuck, right? And now we're going to return, we're going to do like a format string variable, and then with shit after it. Okay, now what's the result going to be? If I run this code again, now what is the output going to be? Give me your best guess. After that, I'm gonna give you a really basic. I want you to try and write. I'll send you a Twitter message. So you won't have to remember everything, but I'll send you a Twitter message, and I'll give you something. Like I'll give you some instructions, and that revolve around everything I've taught you here, and I want you to try and write your own code that does like essentially the same idea. But just give me your best guess of what you think this will output. Super simple. What do you mean? I don't know how delayed it is. I don't think it's like horribly delayed. What do you mean? Is it like censored? We can change the words. If we run this code, what is it going to be? Yes, it's apple pie. Okay. Let's do one more thing. I want you to be able to remember this. It's very important. So let's do arg1 equals pumpkin. Okay. And then we do return arg1 with pi. And we do, actually let's just do arg1. And let's do simple function arg1 equals pumpkin. Print results. Okay, now what do you think this one will be? Let me know when you're back. Okay, so just what do you think the result of this will be? You should be able to get this right. It's pretty simple. Maybe it'll make it easier for you that it's like this. Right idea, but you have it backwards for whatever reason. It's like this. So this again, so this code doesn't get ran. Like when Python interprets this, so let's go ahead and do it with the breakpoint. So I go run this code, and the first breakpoint that gets hit is this one. Why? Because this function does, like, the code inside the function does not get ran. It only gets defined. This code does not actually get ran until this code is ran, right? So now that this breakpoint's been checked, or this breakpoint's been triggered, this breakpoint will get triggered now because this function is here, right? So now, boom, now the first breakpoint has been triggered because the function was actually called, right? So, and then since this function ends, it has to return back to where it was executing before, right? So we return arg1 plus pi, and we go back to executing where we were before, which is here, and then we go to the next line and we execute print results. Results is equal to the return of simple function, right? Which is arg1 plus space pi, and arg1 is pumpkin. So that means arg1 plus space pi is pumpkin pie, right? I think you'll understand it as best as we can for right now. But I'm gonna send you a message on Twitter, and it'll be like it won't be a long. It won't be something advanced. It'll be something you can do within like 10 to 20 minutes. And I want you to write something in VS Code that actually runs. That kind of uses the ideas that I taught you here. But yeah, I'll send you it in a little bit, and try to practice. Try to practice this stuff. Like go into VS Code and write code that does this stuff. Like I'm gonna maybe upload this to YouTube as well. I don't know, but try and use these codes. Like go into VS Code and be like for integer in range 100, and just play around with it. Like print integer, like print length of integer len integer or something, or like print a type, print a value, like whatever, right? Like do like define a function, like modify list variable, like whatever, then call modify list. Like just play around with everything. My theme is called Tokyo Night. I forget what the font is. But the theme is called Tokyo Night, I believe. I have a bunch of like stuff installed. I think I might be using Dracula. I don't remember. I'm either using Dracula or Tokyo Night. But yeah, I'll send you something on Twitter you can do. But yeah, I'll turn off the stream.